Hello, and welcome to my Capstone presentation. My name is Saif Ali, and my Capstone topic is Create and Build. My essential question is, how can I create a desktop PC that is reliable and sustainable for any variety of tasks? In this presentation video, I will be showing you my learning process, interesting facts I learned along the way, the part picking and building process, along with some mistakes and challenges. Stay tuned, I'll show you exactly how I did it. So what made me choose my topic? Well, when I was 8 years old, one of my family friends gave me an Xbox 360. Initially, I had no interest in it, but as time went on, I started realizing how amazing and fun this plastic box is. And as time went on, so did my interest in gaming. Now, you're probably wondering, what does gaming have to do with making desktop PCs? Well, back around late 2017, I was told about gaming PCs and how they are a lot better than gaming consoles. So I decided to do some basic research on gaming PCs, and just like that, my interest in PCs was born. Another reason why I gained such an interest in PCs is back in the summer of 2019. I had an interest in learning Photoshop and Adobe Premiere Pro, so much so that I took some online classes on it, and turned out my laptop from 2013 would not cut it for graphic intensive programs like these. So I had to get a stronger computer to learn and use these programs effectively. I chose to learn how to make PCs as my topic because it relates to my passions like gaming and interests like Photoshop. Also, I just find it genuinely interesting and fun to understand every part of a PC and be able to create a working and efficient one for any task. So what steps did I take to start my project? I started my project back in July of 2020. First thing I did was I went to YouTube in search for some beginner guides to understanding how PCs work. Due to the recent popularity in PC gaming, there was no shortage of videos to watch. It did, however, become rather overwhelming due to a large number of videos and complicated terminology a beginner would find difficult to understand. But that's when I found it. The greatest and most useful, easy to understand PC building YouTube channel for any level of PC builder, Linus Tech Tips. This YouTube channel has it all, from general PC builds to in-depth videos on specific PC parts, from exactly how they work to comparisons of similar models. Their team works around the clock to provide their subscribers with correct and easy to understand videos on all aspects of building and understanding PCs. Linus Tech Tips was the perfect YouTube channel to start my PC building journey. Did I do any research? If so, what did I learn from it? Doing research before you go ahead and buy the components for a PC is crucial if you want to get a bang for your buck and if you want it to work properly. Initially, I did some research on videos that explained what PCs are made of, how they work together, and what each component does. However, these videos are just the fundamentals of PC building and are very simple to understand. Once I had a general idea of what goes into a PC and how to build one, I started to go into the details. This is where Linus Tech Tips really shine because their channel not only covers the fundamentals, but also covers very detailed explanations of all parts of a PC. I started off learning about CPUs, which is called the Central Processing Unit. It's like the brain of the computer. I learned about what a CPU core is, what a thread is, what the letters at the end of the name mean, what clock speed is, and the list goes on and on. Linus Tech Tips covers basically every part about a CPU in great detail in an easy to understand way, so it was only a matter of taking the time to learn. After I had CPUs down, I moved to graphics cards, which have their own special names and attributes, and then to the RAM, and then to the power supplies, and so on until around December 2020, I understood the fine details of all the components of a PC. Another key thing to research when it comes to making PCs is compatibility. You can't just put whatever parts you can find and put together. For example, if you get a top-tier graphics card and put it in a system with a CPU from 2002, sure, it'll work, but your computer will suffer greatly from a lack of balance in performance, causing a great bottleneck, or even in this specific scenario, can even cause your CPU to become permanently damaged due to the power of the graphics card. In order to make a PC that is efficient and reliable, you need to have a good balance in hardware. With that in mind, I first had to decide what kind of PC did I want to make that is suitable for my needs. So let's take into account what I want my PC for. Firstly, I'm a gamer. So I want my PC to be able to run the latest games at a relatively high FPS, which is basically how many frames per second your computer can generate, which will require a good graphics card and CPU. I would also like my computer to be good at multitasking when it comes to doing schoolwork with multiple programs and Google Chrome tabs open, which require adequate RAM and CPU cores. Finally, I would like to be able to do some graphic intensive work with Photoshop and Premiere Pro. In order for these programs to run effectively and properly, once again, I need a good graphics card and CPU. But there was one problem. I had no idea what hardware is appropriate for the tasks I wanted to complete. So I took to a website known as PCPartPicker.com, a platform where people can create virtual PC builds from entry level to the best of the best. All builds have a detailed description of all the parts chosen and how this PC can perform. Another great part of this website is you can create your own custom PC virtually and see the compatibility of all parts. It also shows you a price graph showing the price ranges in the past few months. Another great website is userbenchmark.com. It's a website where owners of all graphics cards and CPUs can test their own products in a benchmark tool and have their results averaged with owners of the same product and compared against the rest, creating a tier list of all CPUs and graphics cards in the market. This is a great resource for any PC builder because it allows you to compare any two products and see realistic game FPS, abilities, average score, and market value. After about a month of watching reviews and looking at benchmarks of similar products, I have decided on exactly what kind of PC is best suitable for me. For the CPU, I chose the Core i5 9600K for 6 cores and 6 threads, which is perfect for running games with a relatively high FPS, rendering and working on graphic arts, and multitasking, all at a reasonable price of $280. Next, I had to choose a CPU cooler, and I chose the Cooler Master Hyper 212, which has a great quality to price ratio. It has a high quality heatsink and fan, and it's quiet, for only $60. Next up, the motherboard. I chose the Gigabyte Z390 Pro Wi-Fi for its Intel 9th generation compatibility, which means my CPU will work with this motherboard, built-in Wi-Fi card, reinforced graphics slot for heavy cards, plenty of USB ports on the back, and I think it just looks really cool in general. The motherboard came down to a total of $260. Now for the RAM. I chose the Kingston HyperX 16GB DDR4 memory. 16GB is more than enough for the majority of PC builds. Getting more would just be a waste. This RAM helps a lot with multitasking and gaming due to its speed and size. The RAM came down to $115. Next up, the storage. I got two different memory devices. One of them is a 480GB solid state drive, or an SSD, which is much faster than the regular hard drives. I got the SSD for the sole purpose of being a C drive, which is only for the operating system Windows and for other administrator level programs like Google Chrome, Microsoft Teams, and any game launchers like Steam or Origin, which was $80. And I got a 1TB M.2 SSD, which is the fastest memory device you can get currently. This device is for all my games and any non-administrator level programs like Photoshop, Premiere Pro, and the list goes on and on. I'll put whatever else I need to put in there like photos and videos. The M.2 was $130. Next, quite possibly the most exciting part to a PC, the graphics card. Now, a thing about graphics cards is that not only are they the best and pretty much the only option for gaming and graphic intensive programs, they are also one of the most convenient and affordable cryptocurrency mining devices. Now, cryptocurrency mining is not at all the topic of this video, but due to the recent rise in the crypto market, most notably Bitcoin, graphics cards have gone almost obsolete from major retail stores. The only way to get one right now is to buy it secondhand, which is not too much of an issue. However, there are lots of scalpers, scams, and cards that have been used to their limit via mining. Finding a good graphics card was tough, but after looking at countless Craigslist and Facebook Marketplace listings, I found it. The Asus Strix GTX 1070 for only $350, which is quite reasonable at the time of recording this video. I talked to the owner and they said the card was maintained very well and in great condition. The graphics card is a very good match for my CPU and RAM, and I could definitely upgrade it in the future with ease. and I managed to negotiate the price down to $300. Now for the power supply. I went with the Corsair RM750 coming in at $125 because it can supply more than enough power to run my components and can even run higher power components in the future. And finally, the case. I went with the Cooler Master MB530P, which was $150, because it can accommodate all my hardware with plenty of room to spare, and also comes with 4 fans, 3 in the front and 1 in the back. Alright, now that I have chosen all the parts, it's time to order them. I am ordering the case over Amazon and the rest of the parts from a local store, Canada Computers, because they have the best prices I could find. In total, the price for this whole build is exactly $1,500 plus tax and shipping. I ordered all the parts, and in a few weeks, it all arrived. Now all that's left is to build it and see how it turns out. Did my final project look like what I had envisioned when I first started? Honestly, my final project looked way better than what I had initially envisioned it hardware-wise and look-wise. I am really happy with how this turned out. It looks great, it's relatively quiet, and it can run all the games I want to with over 125 FPS, which is really good. It can also run Photoshop and Premiere Pro with ease. I can also have up to 20 Chrome tabs open with no issues. Another thing I really like is how upgradable this PC is, because with the motherboard and power supply I have, I can put in a new CPU and graphics card and not have to worry about any incompatibilities or bottlenecks. All in all, I am really happy with this PC and can't wait to see what the future holds for this new skill I have learned. Were there any challenges I had to overcome? If so, how did I do so? The main challenge was the graphics card. As I said earlier, it was really hard to find one that was in good condition and for a fair price. However, with some consistency searching in the market, I did eventually find a good one. Another challenge was the overall availability of the parts. Due to the global pandemic at the time of recording this video, lots of people are stuck at home and businesses have fewer workers. With this high demand and low supply, it's very difficult to get the parts you want. Once again, the way of dealing with this is patience and consistency. What would I do differently next time? Next time I would definitely wait for cryptocurrency prices to drop so I can have a chance to get a better graphics card for a better price. I also would have bought my own case fans because the stock ones are a bit loud and can only run at one speed all the time. Also, this is more specific to the current times I'm in, but I ideally would not make a PC during a global pandemic just so the prices are cheaper overall and that I don't have to worry about availability or any other setbacks. Other than that, I don't see anything I would do differently. In conclusion, I learned a lot about how PCs work and how they are put together. I understand all the components of a PC, how they work on their own, how they work together, and what different models do differently. And I put all my skills to the test by making my own PC in the end. I had a lot of fun with my Capstone project. I feel that this is a great starting point to my future in building PCs, and it couldn't have gone any better. Thank you for watching.